Muscle contraction and relaxation. A stimulus sets up an impulse to travel through a neuron. The impulse travels to the branches of the motor neuron.
Impulse releases the neurotransmitter acetylcholine from the end of the motor neuron into the synaptic cleft. Acetylcholine diffuses across the synaptic cleft at the neuromuscular junction.
The extensively folded sarcolemma is stimulated by the neurotransmitter. The impulse enters the muscle fiber through openings in the transverse tubules. It then travels through the tubules deep into the muscle, stimulating the sarcoplasmic reticulum.
The sarcoplasmic reticulum releases stored calcium ions into the sarcoplasm.
The released calcium ions bind to troponin molecules located along the actin protein inside the myofilament. This binding of calcium ions to troponin molecules causes the rope-like tropomyosin protein to move and expose the binding sites on the actin filaments.
These binding sites are then hooked onto branches of myosin filaments, creating cross bridges between myosin and actin.
The cross bridges pull on the actin, shortening the ioband of the myofilament. This is when a muscle contracts.
Relaxation begins when the enzyme acetylcholine esterase breaks down acetylcholine. With no neurotransmitter present, stimulation of the muscle fiber ends.
Calcium ions that once bonded to tropomyosin are now transported back into the sarcoplasmic reticulum.
With no calcium ions to bind to troponin, tropomyosin covers the binding site of the actin filament again, breaking the cross bridge between actin and myosin.
The muscle fiber is no longer contracting, and the resting state of the muscle is reestablished.